In this video, I'm going to show you four logic rules that will allow you to take given information and make valid conclusions from them. And the first rule that I'm going to show you is called the law of disjunctive inference. And the way the law of disjunctive inference goes is that you're going to be given two pieces of information. And I'm going to organize it in a little, like a two-column chart like this, where the first column is statements and the second column is reasons. And I'm going to tell you two things, so the reasons for the first two things are going to be given. And the two things I'm telling you is that P or Q is true and that not P is true. That's what's given. So when you put these two statements together, the first one says that at least one of them is true. But the second one says that P is false. So the conclusion that you can make is that Q must be true. So if one or the other is true, but one of them is given to you as false, it means the other one is true. It's almost like process of elimination. But the reason that you write is the law of, but you could just write the words, disjunctive inference. Now, sometimes it looks like a little bit different. So here's another one where you're going to be given two things, and from the two things you're going to be able to make a conclusion. I should mention it's good practice, so even though there only are 3 steps, because we kind of utilized steps 1 and 2, you put in parentheses, 1, 2, like those were the two. There could be 10 lines in one of these 2-column things. So someone might get confused, I don't follow your logic. So when they see the parentheses with the numbers, they say, oh, it somehow involves steps 1 and 2. Now this second one is going to look a little different. If it said P or not Q, if that was given, and you're also given Q. So it doesn't look exactly like it, but it actually is, because P or not Q means that one of those things has to be true. But since Q is given as true, that means that not Q is false. So the conclusion is that P must be true. Again, disjunctive inference. So in both of those, we're told in step 2 that one of these two things in the or statement is false. In this one, we're literally told P is false, but this one we're told Q is true, but not Q is in the or statement. So that second one didn't look like it was disjunctive, or you could use disjunctive inference, but you could. And I want to show you a third thing before I go to the next. Just good practice to write parentheses and all the steps that kind of were involved in the disjunctive inference. So here we are given not P or not Q. That's given. And we are given not Q is true. And here, it looks a little bit like disjunctive inference because you have an or statement and something about one of the pieces. But the problem is, we're being told that Q is false, or that not Q is true. So that means this thing here is true. So we can't say anything about P or about not P, because all we know is that part of this thing is true, which means this not P could be true or false. So I'm just going to write no conclusion, can be made. And that is our first rule, which is called disjunctive inference. The second rule of inference, logic law, is called, some people call it detachment, and then there's this Latin expression that also means the same thing. It's called modus ponens. Those are two ways of describing this rule. The way this rule works, again, statements, reasons. In this case, we're given that some conditional is true. And then we're also given that P is true. So P implies Q is true, which at that point we don't know much. It could be that they're both true, P and Q, or it could be that they're both false, or that P is false and Q is true. We don't know for step one. But step two is telling us P is true. So if P is true, basically Q can't be false, because otherwise you'd have, if P was Q and Q was false, then the P implies Q would be false also. So what detachment is basically does, it says if you have a conditional and you're told the hypothesis, the antecedent, the thing on the left is true also, you can conclude that the thing on the right is true. And the reason, I'll just write detachment. And it's utilizing steps lines 1 and 2. That's detachment. Now I could make one that looks a little different, but still is detachment, as long as the first step has to be conditional. And if also given to you is that the left side of the conditional, in this case not Q, if you're told that not Q is true, you're given it, then this is a situation you can use detachment. You can conclude that the right-hand side, the conclusion, is true also. So those are both examples of detachment. Now, just like I did before with disjunctive inference, I could make one. This second one was one that doesn't exactly look like detachment, but it was. Well, this last one is you're given a conditional, and you're told something about one of the pieces. Now, this looks a little bit like a detachment, but it's not, because in detachment, like this and this match, and in this one, the P and the P match, but in this one, the not P and the P don't match. So in order to use detachment, the thing on the left, the hypothesis, has to be given, but it isn't in this case, so there's actually no conclusion. You can't use detachment here. Maybe you could use something else, we'll find out. But that is what detachment is. Now the third law, there's only 4 for this video. The third law is called the law of the contrapositive, and the way it works very quickly is that, and also back here, no conclusion. For the law of contrapositive, you're given a conditional, and you're allowed to just write the contrapositive is also true. So we could just say, I'll just say contrapositive. And I'll even write 1. I basically rearranged the given conditional into a contrapositive. So that's called the law of contrapositive. It's only one. It's there's one piece of given information, and we could jump straight to this conclusion. Now, it doesn't have to be always like P and Q. You could have some nots thrown in there. So not P implies not Q. If that was given, then you could jump using the contrapositive rule to the conclusion Q implies P. Basically negate the two things and swap them around. And that is the law of the contrapositive. So that's 3 of the 4 rules. Now the last rule for this video is called modus tollens. And the way this works is you're given 2 things. In this case, conditional P implies Q. And we're also given not Q, which this is not detachment, because detachment is only if P was given. But watch what I can do. First, we're going to do it in 2 steps, not using modus tollens. So one thing you can do is you can take the first given, the P implies Q, and you could use the rule of contrapositive. With number 1. But now, look at 2 and 3 together now. 3 is a conditional, and 2 is sort of the first part of the conditional established as true. So step 4, I can conclude not P by detachment. And I'll put 3 is sort of the conditional, and 2 is like the first part of it. Now that's not using a new rule. That's just doing 2 conclusions from the 2 givens. But here comes the cool thing here. If I start this question over, modus tollens says that if you ever see a conditional like P implies Q, and the thing on the right, the conclusion, the negation of that is given as true, like it was here, you could jump straight to the conclusion that the negation of the hypothesis, not P, is true also. You could jump straight to, it's almost like detachment, but it's like sort of detachment with the contrapositive. So the reason is modus tollens. Another example where we can use, and my modus tollens is using steps 1 and 2, or lines 1 and 2. Just to have another modus tollens, because I don't want you to think it always has to say P implies Q. Here's the given is any conditional, so that's given. And we're also given Q. And in the next step, I have a conditional, and I have the negation of the thing on the right-hand side. The right-hand side was not Q, and Q is given. So you could combine those, and using modus tollens with line 1 and 2, we can make the conclusion that the negation of the hypothesis, the thing on the left, is true. So that's modus tollens. And I'd like to also show you an example that looks like a modus tollens, but there's going to be a problem. So here's a conditional, and then I'm given Q also. Now this looks like it might be a modus tollens because they were told something about the right-hand side, but it's not the negation of it, it's just irregular. So there is no conclusion can be made. So sometimes it looks like modus tollens, but it isn't. Now we can use these 4 rules to do some multi-step logic proofs. So it kind of looks like this. statements, reason. I'm going to actually be giving you 3 statements that they're going to be given. So there are 3 things that are just given to you, and they are B implies not C, C or D, and not D. And sometimes they tell you like what the goal is, what to prove, but I just want to show you how we can get more true statements out of these. First of all, you'll notice that steps 2 and 3 is an or statement, and step 2 is an or statement, and step 3 is a negation of something. So I can combine those things together using disjunctive inference, using lines 2 and 3, and make the conclusion of C by itself, because it's C or D, but D is false, so C must be true. Now, if you look at 1 and 4 together, I can get step 5, because 1 is a conditional, and 4 is saying the opposite of the conclusion is true. So then I could jump to the opposite of the hypothesis by modus tollens. So that's an example of a multi-step where I combine 2 things, 2 of the givens to get a new thing, and then I combine that with the other given, or basically I'm using 2 lines at a time to create new statements. So that's an example of a multi-step logic proof. Here is another multi-step logic proof, and in this one, because it's actually common that you're given a few things. So here we're given not G implies H. And, oh, by the way, I forgot here, it's 1 and 4 were the modus tollens. The other given is not G. And the third given is not H or J. And sometimes they actually tell you, try to prove that J is true. So they actually tell you what they want the last step to be. It helps sometimes to know what the last step is going to be. It kind of gives you some direction of where you're going. So the first thing I'm going to do, though, is I notice steps 1 and 2 seem to fit nice for a detachment. Not G implies H, and not G is given, so I can say H. And now, 3 is an or statement, and 4 tells me about something in the or statement. So the final step is that not H or J is true. H is true, so not H is false. But the or statement is true, so one of them has to be true, so it has to be J. And the final reason is disjunctive inference. And it was utilizing lines 3 and 4. Okay, well, that's what I wanted to show you in this series of lessons. We learned four logic rules: disjunctive inference for or statements, detachment for conditionals, contrapositive. We actually rarely use that one. I just wanted to show it to you so that we could get the fourth one, which is modus tollens. Really, we only used the first, second, and the fourth one. Okay, that's going to be good for this lesson.